Hello, my name is Hannah, and I'm going to talk to you today about two of the kits we have that discuss the principle of the Coriolis effect. On my left is our Coriolis effect kit, which gets into the mathematical reasoning behind the Coriolis effect and somewhat explains why it happens. And then on my right here, we have our CD spinner Coriolis effect kit, which enables you to build a device so you can actually see the Coriolis effect in action. Let's start assembling it. To assemble the Coriolis effect kit, take the ball bearing top and slide 3 number 2 pencils into the openings on the bottom. Then slide these 3 pencils into the pencil triangle base, add a ball bearing to the top, and then take the top part here for your meter stick and slide it into the middle of the ball bearing so that you now have a freely spinning centerpiece. Then you're going to want to take a meter stick and slide it so that it is centered on your rotational device. Then we provide 2 different types of markers. Once you have them, you can simply slide them onto the edges of the meter stick. Make sure that you set them up equal distances from the center, as these are representing latitudes along the Earth. So you can actually envision these different things as various parts on the globe, where we have the equator on the edges, a higher latitude here, and an even higher one at these. Your students can then do some math integration, so they can calculate the diameter of each of these different markers and then use it to figure out the circumference. From there, they get a chance to look at the amount of distance traveled over time using the circumference values they got to determine which of these 3 markers is traveling the fastest. So that gives you a chance to sort of explain some of the mathematical reasons behind why we see the Coriolis effect. But for your students, it will be really helpful for them to actually see the Coriolis effect in action. So that's what our other kit is for. The CD spinner Coriolis effect kit is a really great way to actually demonstrate the Coriolis effect kit right in your classroom. To assemble it, again, use a skateboard ball bearing and place it on to the CD base. Then take the CD rest and set it on top. And again, you have a free spinning device here. Now, you don't want this to be too wiggly, and that'll depend on your printer's level of variance when it prints. So if you want it to be a little bit more solid, you can take some tape and tear it in half, because you don't want it actually interfering with the ability of the ball bearing to spin. But then just slide it around to make the ball bearing a little bit bigger so that it fits into this opening just a little tighter. Once you've verified that it's spinning freely and not too wobbly, you're going to need to get the CD ready. So use the provided CD spinner kit protractor and a ruler. Simply mark 1 line from the center to the outside of the CD. You'll use this as a reference point in being able to tell how your marble is traveling when it goes down the ramp. So take the CD and then place it on top of your CD spinner here, and then secure it using the flexible filament ring that goes along the top. Then simply place your ramp so that it lines up with the line that you drew on the CD so that it would travel in one smooth motion. Secure in place using tape. Next, you need to prepare your release mechanism. To do so, take a number 33 rubber band and loop it through the opening at the top of the release. Then slide the large side of the rubber band through the small loop and pull tight. Then you can insert it into the opening on the ramp and add the marble behind it so that it's ready to go. Now you are looking at a polar view of the Earth. And which pole you're looking at depends on how you choose to spin the CD. If you spin the CD in a counterclockwise manner, then you're looking at the northern hemisphere, the North Pole. And if you do it in a clockwise manner, it's the way it would behave in the southern hemisphere. So let's give it a spin and see what it does. As you could see, when it was rotating in a counterclockwise direction, the ball appeared to deflect to the right. In the same way that on the northern hemisphere, the prevailing winds have that same sort of deflection to the right, which causes a lot of our weather patterns. Now if I were to do the same thing but from a south pole here, I'm going to want to spin this in a clockwise direction and do the same thing. Only this time, the ball appeared to deflect to the left. So we hope your students enjoy getting a chance to see the Coriolis effect in a small environment here using a CD, and that they enjoy understanding the mathematical explanation for why it happens over here with our Coriolis effect kit. So whichever one of these two kits we're using, we hope it really influences your students' ability to understand and comprehend some of the complex topics surrounding weather and environmental impacts of the Coriolis effect kit on our everyday lives. Thanks for listening and have a wonderful day.